Hello everyone, we are from Kongunadu College of Engineering and Technology. On behalf of Department of Electronics and Communication Engineering, I am going to present a first year report of the proposed project design and development of low power consumption and portable device for finding a trapped people during the disaster scenes using a YV technology, which was sponsored by AICT and a research proposal scheme in the year of 2022. The main objective of this proposed project is to develop a through-wall virtual imaging using a YV technology to see the moving objects and their relative locations. This project is to build a device which can able to capture the motion of humans behind a wall or in a closed rooms or any other collapsed surface. The ultimate goal of this project to identify the number of people in a closed room and their relative locations during a disaster scenes. As a result of this project can able to determine the presence of target's location during a disaster situation and also to find the depth inside the room. To implement this project, this is going to use one of a YV device, that is nothing but it can able to transmit and receive. So for that it is going to use one of a transceiver which can able to transmit a 2.4 GHz of Wi-Fi signal, and it can able to get back the reflected signal. This YV device can able to transmit the 2.4 GHz signal, and the signal will pass through the wall. That's why the technique called as a through wall virtual imaging technique. This signal will pass through the wall and hit on the target location behind the wall and get reflected. The reflected signal will received by the receiver. So to implement this whole setup, we want to use two different types of the transceiver device. So let me see the demo. Let me see the experimental setup. So for that, here we are using a USRP device, which is a one kind of a transceiver which consists of a two antenna port. One is a transceiver port which can able to transmit and receive, and another one is a receiving port. So here we connected two antennas for transceiving and receiving purposes. So which was connected to system, and this USRP will be configured by using the LabVIEW software. So this LabVIEW software, it is a block diagram part, and it also consists of the front panel. So this for the implementing this project, we want to configure this transmitter as well as a receiver separately. So this is the block diagram for the transmitter, and this right side part will explain the block diagram for the receiver. So first let me see about the transceiver part. So this transceiver part consists of the open transmitter section, which you can able to configure the transmitting antenna, and it also consists of the configuration signal. It will configure the what is the carrier frequency and IQ rate of the signal. It is nothing but we are transmitting 2.4 GHz of sinusoidal signal, and which will be entered into an antenna by using the right transmitter data panel. Then after it, the transmitter will get end by using the closed session. So similarly, we want to create a block diagram for the receiver section. So this receiver section also consists of the open receiver section, which will start receiving the signal. Then after, it also consists of the configuration part, which will configure what kind of signal it want to receive. Then it consists of one more additional signal. It is nothing but the initiative block, which will start the initialization of the reception. So for that, we want to add this initialization block. Then after, it consists of the fetch data, then end reception part. So this is the block diagram setup. So now I am going to start the transmission. So for that, I am clicking the run icon. Then we can able to see here this transmitter is transmitting, which will be indicated by the red color LED. So then, and in the same way, I am clicking that run icon of the reception part. So we can able to see here the receiver of that RX2 also receiving start reception. So this transmitter is transmitting a 2.4 GHz of a sinusoidal signal, and the receiver is receiving that sinusoidal signal transmitted from the transmitter. So let me see the output. So this is the signal what we are transmitting. This is a sinusoidal signal we are transmitting to transmitter, and this is the receiving signal we got from the receiving antenna. Whenever any human object detected, the signal frequency will be vary. So now we are going to, afterwards we are going to analyze that frequency value got from this receiving antenna by using the signal processing toolbox. As I already told, to implement this YV setup, we can able to use two different types of transmitter and receiver device. So still now we had used a USRP device as a transceiver to transmit and receive the Wi-Fi signals, and also we can use some other types of a transceiver. It is nothing but a STR. This is software defined radio, which also consists of that two transmitter and two receiver ports. We can able to configure this with our setup. So this STR can be able to configure by using the GNU tool, which was shown here. As similar to the LabVIEW, here also we want to create a block diagram for our hardware setup, and then we can able to configure the transmitter and receiver separately. This top part will be used to configure the transmitter, and this bottom part will can able to configure the receiver part. So as I already told, to implement this project we want to transmit a 2.4 GHz of sinusoidal signal. So this signal source will send a sine wave, and we can able to configure the frequency range and what are the device setup, everything over here. This is the block diagram for the transmitter. Then after we want to configure the receiver. Similarly, what kind of signal I want to receive and what is the device name, everything we want to mention manually. Then after it will be displayed in that display panel. Now let me start the simulation. Then it will automatically open that simulation panel. Here we can able to see that output and in a different domain. So let me see the output in a time domain, then we can able to analyze it easily. So this is the transmitter and this is the receiver, whatever that we are transmitting and receiving through that antenna in the STR. So this as similar to that last setup, it also can able to find out whether there is a any human body motion in front of that antenna or not. So whenever any human body objects or come nearer to the antenna, automatically the signal frequency will vary. So that is what we are going to analyze. By using that MATLAB signal processing tool, we want to analyze that how many people are there, whether the people trapped behind the wall or not. So likewise we are going to analyze further. Thank you.